Okay, hi guys. We'll just do a short lesson on the trigonometry review from last semester. So what we have here is the function f of x equals a sine k x minus c plus d. It could be cos as well, but we'll just start with sine. So just recall that a is the amplitude. Okay, k is the horizontal compression factor. Okay, and just remember that the period is equal to 1 over k, and similarly k is equal to 1 over the period, and c represents the phase shift, okay, which is horizontal, and d represents the vertical shift. Okay, so the first example, given the function y equals 2 sine 3x plus 1, determine the following. So the amplitude is equal to 2, the period, we'll go back here, is 2 pi over k, and it's 2 pi over the period. Okay, the period is equal to 2 pi over 3. The phase shift, there is no c value, so it's none, and the vertical shift is up 1. So now we're looking at the max and min y values. So if we just ignore the 1, the amplitude is 2, which means that the curve goes 2 above and 2 below the x-axis. So we're adding 1, we're shifting it up 1. So the new max is going to be at 2 plus 1. And then the new min is going to be at negative 2 plus 1, which is at negative 1. And now the next part says the values of x at each max or min. So a couple different ways we can do this. The first thing is we can sort of like roughly sketch it out to see what it looks like, right? So what we have here is we have our initial sine function. Okay, I'll just break it up into our intervals. So we'll go for like that. Okay, so the period is 2 pi over 3, okay, which is like 120. So we're going to draw the curve that looks like this. Okay, and then what happens is we get shifted up 1. Okay, looks something like that. Okay, now we know that the max occurs at a quarter of the period, and the min occurs at 3/4 of the period. So if we take a quarter of the period, we have our 1/4 times 2 pi over 3, okay, which is, and that we get 2 pi over 12, which is at pi over 6, okay, and this is where the max occurs. And the min occurs at 3/4 of the period, so we have 3/4 times 2 pi over 3. We can cross that, cross that, cross that, cross that, get a 2, and that occurs at pi over 2. Okay, now our two special triangles, we have our pi over 4. Remember, pi is, in the conversion, that's 180 degrees, so that's pi over 4, it's our 45. And this is our 30-60 triangle. So the first one I have is sine of 3 pi over 4, determine the exact value. Okay, so we use our CAS rule along with our special triangle, so I'll draw this one out here. So 3 pi over 4, remember 4 pi over 4 is right here, which is pi, so 3 pi over 4 is in this quadrant. So we're going to draw a triangle like this. And our related acute angle is pi over 4. So that is pi over 4 there. Okay, so now we're just going to put our numbers in. So opposite goes 1, adjacent goes -1, and then we have root 2. So the sine is 1 over root 2. Okay, now cosecant pi. So remember what cosecant is. That's 1 over the sine of pi. Okay, and the sine of pi. Okay, if we go here, remember sine is sort of like the height of the triangle, so at pi it is 0. So we have 1 over 0, which is undefined. Okay, now the last one is cosine of 11 pi over 6. So we're going to draw our Cartesian plane, and 11 pi over 6, that is down in quadrant 4. Okay, and because it has a 6 there, that means that this angle is going to be your pi over 6. That one there is going to be your pi over 3. Now your opposite of pi over 6 is 1. Because it's below the axis, it's negative 1. Your adjacent to pi over 6 is the square root of 3. And your hypotenuse is 2. Okay, so the cosine is your adjacent over hypotenuse, which is the square root of 3 over 2. Okay, perfect. Now I'd like you guys to try from page 212 to 213. Let's try let's try 1. Let's try 6a and b. And let's say 7. And then you can try a couple of identities. Let's try let's try 14d. Okay, and that's it. I'm going to send out a Google Doc to make sure you guys can all open this. I'm going to send it as a compressed video file. So just let me know if you can open it. Thanks.